Okay, this video and this worksheet are going to go over some prerequisites for Unit 2A. So these are things that you should have seen before, and I want to make sure that you remember before we start going into the unit. If you find as you go through this that there are things you need to come see me about, please do that so that I can help you. For 1 and 2, we're writing out our perfect squares and our perfect cubes. So what I would tell you to do is write out 1 squared, 2 squared, and so on the squares all the way until you get to 20 squared. Write out those numbers. And for the cubes, you're going to do the same thing, but 1 cubed, 2 cubed, so on, all the way to 10. The reason you're only going to 10 on your cubes is those numbers get way bigger, way faster. But all of these numbers are going to be important. You'll notice on this part I have different problems with you, so these are good examples. If you want to write them down in your notes to have that, or if you want to put them somewhere else, that's fine, but these are different examples, and then you'll attempt to do yours based on these. When we are simplifying square roots, you should have done this definitely in geometry a little bit. You also probably saw it in Algebra 1, depending upon your teacher. When you're simplifying, you're trying to divide out the biggest perfect square that you can to shrink down your numbers. So my first step here, and we will go over this in class, but it's going to be helpful if you already know some of it, is to find the largest perfect square that divides into your number. Whatever's under your radical. That's called your radicand. We'll go over that in more detail later. So what I'm looking at here is this 320, and I'm saying, okay, what of my perfect squares, so the numbers that you should have written down here, what of these numbers divides into 320 evenly? Some people do this from big numbers, some people do it from small numbers, but you want to figure out which ones do. So if you start small, you could just do divided by 4. You know that 4 goes into 320 80 times. So in my calculator, I just typed in 320 divided by 4. You can do 320 divided by 9, and you get a decimal. 320 divided by 16, and you get 20. So 16 times 20 is 320. 320 divided by 25. Again, I'm only dividing in my perfect squares, and you get a decimal. 320 divided by 36, and you get a decimal. Divided by 49, and you get a decimal. 320 divided by 64, and I get 5. You can keep going. What I will tell you, especially as you're now in Algebra 2, and I want you to be thinking through your work, if your second number is prime, so because this 5 is prime, that means nothing bigger will divide into 320. And so I'm going to leave it like this. I know that's my biggest perfect square that will divide in. Your second step then is to rewrite your problem. And I'm just going to replace this, instead of square root of 320, I'm going to write it as square root of 64 times 5, because those are equivalent values. And I've just rewritten it because you're going to be able to simplify your problems. And what I mean by that, you know that the square root of 64 is 8. So instead of writing a 64 in a radical, I can write an 8 outside of a radical. This 5, though, can't come out of the radical, so it will stay in, and my answer is 8 root 5. I'm going to talk through a couple more of these just so you have some examples, and then whenever you are ready to try the ones on your worksheet, I would pause the video and take a second to do that. On 45, the biggest perfect square that goes into 45 is 9. It's 9 times 5. So then again, you rewrite it in the radical. And then I'm going to go ahead and simplify. The square root of 9 is 3. This 5 can't come out, so it's 3 root 5. So my answer is 3 root 5. On 128, biggest perfect square that divides into 128, and 128 does have a few. Remember that you always want the biggest. The biggest is 64, and it's 64 times 2. Then you rewrite your radical. And then you're going to simplify this. So the square root of 64 is 8. I do not know the square root of 2. So my answer is 8 root 2. Your goal here is to shrink down your numbers. So my numbers at the end are much smaller than my numbers were at the beginning, but these have equivalent values. If you type square root of 45 in your calculator and you type 3 root 5 in your calculator, you will get the same answers. Just to give you a couple more examples again, 392, the biggest perfect square that goes into 392 is 196. That was 14 squared. 196 times 2. When you square root it, this is 14 root 2. Your biggest perfect square that goes into 80 is 16. 16 times 5. When I rewrite it, and then I'm going to square root it, square root of 16 is 4. So this is 4 root 5. Last but not least, with 252, my biggest perfect square was 36. Square rooting that gives me 6 root 7. Okay, I would encourage you to pause the video, try some of these, make sure you get the right answer, because I talked through them kind of quickly once we went over them. So make sure you pause and rewind as you need to. This next part is a challenge that I want you to think about. We will be teaching you this later in the unit, but if you've thought about it beforehand, it can help. Think about how we simplified our square roots up above, and think about how that can apply to your cube roots, because it's actually the same process once you think it through. So those are some challenge problems for you to try. The back of your worksheet then is going over your exponent rules. Your 13 through 17 should be the exact same as mine. And so I would fill this in. When you multiply your like bases, you are adding your exponents. So that's going to be really, really important here. What that means, if you're doing, if you are doing x to the b power times x to the a power, you will rewrite this as whatever b plus a is. So if I give you a simple example, x squared times x cubed, it's really x to the 2 plus 3, or x to the 5th. This is something you should have done back in Algebra 1, but I know it's been a while. 14, when you divide like bases, you are subtracting your exponents. So again, I will write this out in a mathy way and in a I'll give you an example. So here, if it's x to the b over x to the a, you are subtracting. You'll do x to the b minus a. So for example, if it was x cubed over x squared, it's really x to the 3 minus 2, which is just x to the first power. Okay, the whole idea there is that those were canceling out, and that's why you subtract them. The next rule, when you raise a power to a power, you multiply your exponents. And what that looks like, if I have x to the b raised to the a power, I will do x to the b times a. So x squared cubed tells me to do x to the 2 times 3, or x to the 6th. The reasoning for that, if you don't remember for Algebra 1, I'm just going to write this off to the side. X squared cubed is really 3 x squareds. And then this would send us back up to our addition rule. And we do 2 plus 2 is 6. So this rule kind of lets you bypass that. The next thing you should have seen in Algebra 1 was your negative exponent rule. What your negative exponent rule tells you to flip where it is in your fraction. Not necessarily the whole fraction, but just the piece that's negative. Okay, so x to the negative n is really 1 over x to the n. Or if it started as 1 over x to the negative n, you'd put it on top. So you just move it where it's at in the fraction. The last rule is your zero exponent rule. And what it tells you, if you have anything to the 0 power, that always equals 1. No more exponents, no more anything. So I'm going to talk you through some of these examples. Again, my examples are different than yours so that you have plenty to practice from. But I'm going to work through a few of these to help you out. The first ones all started with different numerical bases and different exponents, because you can do this whether your base is an exponent or a variable. Number 18, those are multiplied. They should be on yours as well, which tells me I can do 4 to the 4 plus 4. I can add my two exponents together, which gives me 4 to the 8th. There's no need for you to actually give me the number. I just want you to, combine your exponents for me. On my number 19, I have some negative exponents. So I can start, though, by following my rule that tells me to add them. So this is 3 to the negative 4 plus negative 1, or 3 to the negative 5th. Your directions, as you'll see, tell you to keep only positive exponents. So after I follow this rule, now I'm going to go ahead and follow the negative exponent rule and flip my fraction. When I do that, the 3 to the 5th goes to the top bottom, and it's positive now. And now there's just a 1 on top. For the next two on mine and on yours should both be dealing with your power property. What this is telling me to do is to multiply the 4 and the negative 1 together. So 3 to the negative 4 would be my answer. And again, because it's negative, now it goes to the bottom. Number 21 here, 4 times the negative 2, since that is my power property again, would give me 4 to the negative 8. And again, anytime you have a negative exponent, put it on the bottom. 22 and 23 should be dealing with your division rule. 22 is kind of a special one, so we're going to work through this a little slowly. What I would recommend you do first on number 22 on mine, if you have any negative exponents, I would deal with them here. So this 2 to the negative 1 is really going to go up top, and this 2 to the negative 2 is going to go on the bottom. So this is 2 to the first over 2 squared. When you're doing your division rule, you can do it a couple different ways. You can always subtract the bigger one and then make sure you put your answer wherever that bigger one was, or you can always do top to bottom and follow your negative exponent rule. So if I always do the top minus the bottom, this would be 1 minus 2 for the top minus the bottom, which would give me 2 to the negative first, and then I would flip my fraction since that 2 is to the negative first power. 23, if we subtract our exponents, the 2 minus 2 gives me 2 to the 0, and your 0 exponent rule tells you that anything to the 0 power should be 1. So the rest of these are going to start making you do this with multiple rules floating around. So again, I'm going to talk through a few of these. There are multiple ways to deal with these. There's not only one path to take to get the right answer. So I'm just going to talk through some ideas. When I look first at my 24, again, ours are different. Yours are probably similar though. I want to deal with this power rule first because I have this going on. So I'm going to multiply this 3 times this negative 1. So this is 2 to the negative third. You can deal then either with your negative exponents or with your addition and subtraction. If I deal with those negatives first, again, anything that's negative is going to switch spots. So this is going to go to the bottom to make it positive, and both of these will go to the top. So it'll be 2 squared times 2 cubed over 2 squared. Add your exponents on top. If I do 2 plus 3, this is 2 to the 5th over 2 squared, and now it's just my division rule. So 5 minus 2 gives me 2 cubed, and that would be my answer. Looking at this 25, again, I would deal with my power property first. So this is 2 to the 4th times 2 to the negative 8th, all over 2 squared. Personally, I would deal with this negative exponent. So this term only goes to the bottom, nothing else will change. So it's 2 to the 4th over 2 squared times 2 to the 8th. Then I would deal with my multiplication on the bottom. So that's going to be 2 to the 4th, because that didn't change. 2 squared times 2 to the 8th is really 2 to the 10th. I'm going to talk about this one as if you always subtract the big minus small and how you would do that. So here, if I do big minus small, I'm doing 10 minus 4 is 6. But those 6 2's need to be on the bottom. There's nothing left on top, so I'm just going to put a 1 there. So my answer here would be 1 over 2 to the 6th. If you did it the other way, it will still work. You would do 4 minus 10 would give you 2 to the negative 6th, and then it would tell you to flip your fraction. Either way works just fine. Okay, for these last ones on mine and on yours, I've thrown in some variables to make sure you can handle those. On here, you can deal with the multiplication or the power property if you want to first, but I would simplify the middle because I notice that I have multiple x's and multiple y's, so I can deal with those. So I'm just going to leave the 2 in front. If I do the x to the negative 3 times x squared, I'm adding my exponents. So this is going to be x to the negative 1. Then if I take my y's, y to the negative 4 plus y to the positive 4 gives me y to the 0. All of this raised to the negative first. What you can notice right off the bat, this y to the 0 is really just a 1, so that's going to go away. And then this negative 1 is now only multiplying by 2 things instead of everything. One of the most common mistakes here is multiplying the negative 1 by the 2 directly. Make sure you're multiplying your exponents. So this is really 2 to the first power. So this is going to be 2 to the negative first when I do 1 times negative 1. And then it's x to the negative 1 times negative 1, or positive 1. Lastly, I've got to deal with my negative exponent, so this is going to go to the bottom of the fraction, so this is all x over 2. Okay, going to the next one. If I deal with this first, that 2 is going to come in, so I'm just going to leave my a cubed b to the negative 1 times, this is 2 squared a to the 8th. Then I have really a multiplication rule happening. 2 squared, you can leave as 2 squared or write as 4. I'm not going to be picky there. But when you do a cubed times a to the 8th, you add them. So this is a to the 11th. And then this b to the negative first, if you want to move it down immediately, you can. So this is over b to the positive first, and that's my final answer. Okay. On the next one, again, I usually deal with my negative exponents first, as well as condensing what I can. So if I deal with those first, I really have 4. I have this y on top, and now y to the 4th from coming up from the bottom, over x y squared times 4, and then x cubed. Condensing what I can top and bottom, this is 4y to the 5th over 4x to the 4th y squared. Continuing simplifying these 4's, just divide out, and then I'm just worried about my division rule with my 2 y's right here. 5 minus 2, since this is division, should be y cubed over x to the 4th would be my final answer. Okay, going to the next one. Again, I'm going to simplify this bottom as much as I can. This x cubed goes up top, so this is going to be 4yx cubed over, and I can kind of put some of this together while I go. I can do 3 times 4 is 12, times 2 gives me 24. I have a y cubed and a y to the 4th, which gives me y to the 7th when you add those, and just this x cubed. Then continuing simplifying, this x cubed over x cubed, you subtract those exponents, they cancel, so this is just going to go away. 4 over 24, you can simplify, and it's going to give you, you can divide a 4 out of both of them. So on top you have a 1, on bottom you have a 6. And then looking at my y's, I have 7 on bottom and 1 on top, which means you'll have 6 left over on bottom. I'll talk through a couple more. Remember, you have similar examples on yours, so I would do those as well while you're working through these. Pause it as you go through, or just go back through at the end is fine. Here, first thing I would look through is dealing with that exponent rule. So the top I'm going to leave. On bottom, this 2 comes in, so it's 2 squared times x to the 4th. Then when I look at this, you can treat these 2's as exponent rules. This is really a 1. So I'm doing 2 minus 1 since they're divided. So I will have 2 to the 1st on the bottom. My x's, I have 4 x's on bottom and 1 on top, so I can do 4 minus 1 is 3, and those 3 x's will be on the bottom. And then this y cubed has nowhere to go, so it stays right there. Lastly, on this one, I would deal with my power property first. So this is going to be 2 to the 4th, y to the negative 16th, over x to the negative 3rd, y to the negative 1st. Deal with all of those negatives. Make sure when you deal with your negatives, you only move what was negative. So this 2 to the 4th does not move. But now it's x cubed y over y to the 16th. And then my y's do simplify. I have 1 on top and 16 on bottom, so that means I'm really just going to have 15 on the bottom. That 2 to the 4th you can multiply out or just leave like that. So use these examples as your notes. Whether you needed to write them all down or not is up to you. And now you should be able to go through your worksheet for next time. Again, your exponent rules and your radical rules are going to be extremely important in this chapter. So I would make sure that if you need assistance with them before we get going in the unit, that you do come and get that.